Hello everyone, welcome to the class ECE317 Digital Signal Processing. Today we will keep working on the linear phase filters, linear phase systems. ECE317 for the 13-week Friday's class. Okay. So we consider a system like let's say the h of z, and you consider system with x is the input, y is output. Then the frequency response is h of e to the j omega. If we replace this z by e to the j omega, then we have frequency response. For frequency response, we can write it as a multiplication of two parts. The first part, it is the magnitude of this h of e to the j omega, and second part is it is exponential power, and the power is j, the square root of -1 times omega times angle, the angle of h. Okay. We can always have this. Then for linear phase, what is the linear phase system? So if the angle of h e to the j omega equal to some negative r times omega, then h is linear phase. H is linear phase. If we give a graph for this phase, it will look like depending on the value, the positive or negative of alpha, so go like this way or this way. So I put it like this way. Things like that. From 0 to pi. I gave half of the period. It's a period, right? So this is half cycle, and you can extend to the negative pi. It should be symmetrically. It's an odd function. This is always odd. This is always odd function. So this side you can extend to negative pi, and then every 2 pi you can copy it. Right? So usually you give just give the line from 0 to pi. That will be enough. And sometimes maybe it looks like this. The graph maybe looks like this. The distance between here, suppose this is a 0, this is a pi. This distance should be 2 pi. The distance from this point to this point. So if you look at the graph, these two lines, they are two lines, right? They are not the same one. However, the distance here is 2 pi. As an angle, these two angles, they are same angle. So, in the sense of angle, these two lines, it is just one line. These 2 points, the same point. Alright? Yeah, makes sense. Okay. Like this. It's a linear phase. And this R, it is a slope. Slope of this line, right? This slope. It is also the delay. Delay means if input is a cosine of some omega 0 n, then the output a cosine or sine or e to the j omega 0 n, this kind of things. Then the output side, it will be a magnitude is changed by the amplitude changed by the magnitude, and here's the time. This I don't have enough space. I put it here. Times cosine of n omega 0 n, and shifted by that alpha. I can write in this way. I can write this way. It's a time minus alpha, just a shift of alpha. So you can think it's a delay. This alpha is just that delay. Delay you shift it to alpha. But of course, when alpha is n is a constant, when alpha is a constant, when alpha is an integer, this is really a shift. If alpha is not an integer, this is kind of shift, not really shift. Right. So this is the linear phase. This is linear phase. Then we consider more general case. If the angle of h of e to the j omega equal to some still straight line, but some negative omega r alpha omega plus some beta, then h of z, this system is general linear phase. A general linear phase. General linear phase. You know, we have a beta here. So in this case, the graph, the beta might be different. You know, the beta might be different. The things looks like you will have some straight line, maybe several pieces from 0 to pi. And the start point here, maybe it is not 0. Like in this case, no beta, it just start from 0. Here it is still straight line. Slope is still alpha, negative alpha. Negative alpha is slope. The negative of the slope. Alpha is negative of the slope. It is a delay. Here the slope is negative alpha. Yeah, slope is still negative alpha, but it is not a straight line. Not one straight line. There's several straight line. And the start point, this point is maybe it's still 0, but maybe not. And the distance here, not 2 pi. Not 2 pi. If it's 2 pi, some distance there 2 pi, then these two lines should be combined together. And maybe you still have some, like this gap is 2 pi, but at least you have some, they are not 2 pi. Or here is not cross 0. So as a formula you can write in this way. You have some beta. You have beta. Beta is not unique. It depends. Yeah. So things like this. Then this slope, how to describe this? We call alpha. Alpha now is called the group delay. Called the group delay. Group delay. Right. Alpha is a group delay. It is not really delay, but we call it group delay. Group delay. Okay. Then we can have more general. Actually, what is group delay? Generally, in general. Okay. Now it is not a straight line. The angle. There will be some curves, like some curves, not straight line. Not straight line. Line or lines. Then we still can have group delay. We still have group delay. Group delay. We denote it as tau of omega, or group delay of h e to the j omega. This is notations. We denote by this one. It is defined as negative, then derivative of the angle of h. Like this. You take derivative. What is derivative? The derivative should be the slope, right? Derivative is the slope. So same meaning here. The derivative is just a slope of this straight line. If they are straight line, the slope is just this derivative. But we put the negative. We use this. Add a negative. I get the group delay. So here is like another word is a group delay What is group delay? It is negative of the slope, right? Yeah, group delay. Group delay is negative of slope. So here is what is a group delay? It is negative of the slope. So you can think this is a kind of a generalized of the concept, the delay, right? Delay. Here is a real delay. Here is a kind of generalized, and now we give more generalization, right, for the group delay. Okay, so this is a group delay. Yeah, this is just a concept. If you want to calculate, you want to find it. Okay. All right. Then for the linear phase system, we can have another way to describe it. We use the impulse response to describe it, but we have restriction on that way. That way we need the system to be FIR field. So now we consider FIR filter. We of course here we just consider the linear or general linear phase. A linear or general linear phase. Linear phase or general linear phase. The FIR phase. Of course, we also need their causal. Yeah, we have three conditions: FIR, causal, and generalized linear or linear phase. So what are these kind of filters? Actually we have four types. Last time we introduced two, so I gave them in terms type by type. So type 1 can have the feature like this: h of n equal to 0 if n smaller than 0 or n larger than that 2 alpha. Remember last time? If you check the notes of last time, you should know here's 2 alpha. I write that 2 alpha as m. And if n is if lowercase n is between 0 and m, then they have this case. We have this is h of 0 equal to h of m, h of 1 or equal to h of m minus 1, h of 2 or equal to h of m minus 2, like this. Yeah, it's kind of even. This is a m, this is n equal to m, here's n equal to 0. So these two elements, they are same. These two elements, they are same. This element, they are same. If we have more, like this, or like this, maybe the little one, the middle one like this, things like that. All right, yeah. These 0 and m, these two, they are same. 1 and m minus 1, they are same, and so on. And all of these, we can write it in a uniform way. It is hn equal to h of m minus n, right? Yeah, this is m, this is 0, right? M minus 1, here's 1. M minus 2, here's 2. So m minus n, here's n. They are same. And n will be a value between 0 and m, like this. So this is type 1. We call this type 1. Here m is even. In other words, m equal to 2 alpha. Alpha is integer. Alpha is an integer. Yeah. Like this. So for this kind of thing, then we know, we say h of z is general linear phase system with group delay R. This is just group delay R. So here we can only if you just have this one, you know it's a generalized phase. We can only have group delay, not delay. If you want to delay, you need to do more works. Okay. Now h of e to the j omega will equal to summation of h of n times e to the negative j omega n. Right. This is the definition of the frequency response. And we have this feature. Symmetrical feature. So we only need the summation for n run from 0 to n. But we only need half of it. I say this is 0 to r, to this r. Here's a h of n plus h of m minus n. Sorry. Equal to h n equal to 0 to r. Here's h of n times e to the negative j omega n plus h of n times e to the negative j omega m minus n. Because this one, h of n, it is just h of m minus n. So these two terms, right? This one actually it is. This one is, I just use n drawn from 0 alpha, and this term, according to the in term capital M minus n. So like this is m, this is r, and these terms according to these terms according to this. Then you do summation, all of them you do summation, you have capital H, right? Okay, then this one we can remove. We remove the middle of these two. This one is the index is n. This is a m minus n. So n plus m minus n divided by 2 is what? This is m over 2, which is r, right? Yeah, this 2n cancel, which is r. So the middle of these two, it is just e to the r. I remove that e to the negative j omega r, right? Move it out. And then inside this summation n run from 0 to r, hn, there are still h of n. And the first term, after I remove this one out, then I have e to the negative j omega, now n minus r, right? And this term, both have same coefficients. I put coefficient here. And this term, after I remove r, I have e to the negative j omega m minus n minus r. I have these. But m minus alpha is what? Is alpha, right? M minus alpha, it is just alpha. So this is n run from 0 to alpha, h of n. These two terms, they are e to the negative j omega n minus alpha plus e to the j omega. Here's a m minus n minus alpha equal to alpha minus n. So this is a negative alpha minus n. I move negative inside. This is just n minus alpha. I'm writing this way. Okay, and all of these times this one. Oh, I do not have space. I put it in front already. This is e to the negative j omega alpha equal to this. Alright, equal to this. And this is what? You see the index? They are just they have differences. This is negative, this is positive. So this is just 2 of cosine omega n minus r. It's just like this. Yeah, this summation of these two is just this one. So you see, this whole part, this is real. This is real. I denoted it as hr of e to the j omega. If HR e to the j omega larger than 0, larger than or maybe equal to 0 for any omega, then H of Z is linear phase. If we do not have this, it is just the general linear phase. Yeah. So this kind of system, it is always general linear phase. Some case it is linear phase. You need to check this part whether it is positive. All right. Okay. This is a type 2. Type 1. Then we have type 2. Type 2 somehow similar. We still have this h of n or equal to 0 if n smaller than 0 or n larger than some m or equal to 2 of alpha, but alpha is not integer. Alpha is not integer. Yeah, we can say another word. That means m is odd. Right? M is odd. And the first time we can say m is even. First type 1. Type 1 here. M even. M is even. So type 1, m is even. So you divide m by 2, you get alpha. Alpha is an integer, right? Yeah. And now m is odd. So this alpha is not integer. Right? Then everything, other part are the same. H of n equal to h of m minus n if n is a value between 0 and m. This is type 2. It is also generalized. A general linear phase. Whether it's linear, this is general linear phase. It is a linear phase if HR is always positive, right? Yeah. And then we have type 3. Type 3. It is still Hn equal to 0 if n smaller than 0 or n larger than some m. M is even. That means alpha is an integer, right? M is 2 alpha. Alpha is an integer. And Hn equal to a negative h of n minus n if 0 between n to m. Alright. And type 4, h of n equal to 0 if n smaller than 0 or n larger than m. Now m is odd. This is still 2 alpha, but the alpha is not integer. And Hn is still negative h of n minus n if n is run from 0 to capital M. We have these. Yeah, all of these, they are general linear phase. All type, all about general linear phase system. with group delay R, which is M over 2. This group delay. The group delay. You can also describe it angle of h of e to the j omega is equal to negative alpha n plus some beta. Beta is not 0. It's not 2 pi something. It's depending on the system. Okay. Now maybe sometimes they are 0 or 2 pi. In that case, the system is linear phase. For linear phase, you can just check HR. If HR e to the j omega larger than 0 for omega run from 0 to pi, actually from negative pi to pi, right? We just check this part, it will be fine. H is a linear phase. So we have this. All right. Now we can look at some examples. Actually, for type 1 and type 2, we already have some examples last time, right? So now let's consider type 3 firstly. We have h of n looks like this. Suppose I have 1, 2, and negative 2, 1. Okay, so this is what? You see? This one and this one, negative 1 here. Negative 1. This value is 1, this is negative 1. This is 2, this is negative 2. So this will be type 3 or 4. And here, m equal to, 0, 1, 2, 3. M equal to 3. So m is odd value. So this is a type 4. Type 4, general linear phase. FIR causal system. Alright. Now whether it's a linear phase, you need to more calculate. You check h of e to the j omega, which will be h0, it is 1. Then h2, it is 2 times e to the negative j omega, and this is h of 0, this is h of 1, and then h of 2, this is negative, minus 2 e to the negative j 2 omega. This is according to h negative 2. H of 2 is negative 2. H2 is negative 2. I should choose different value. A little bit confused. H2 is negative 2. Alright. And then H3 is negative 1. So it just minus e to the negative j3 omega. This is according to h of 3. Right? Okay. Then we removed one of the exponential power out. The power will be in the middle. So there will be 1.5, right? The middle is here. It's alpha equal to 1.5. Yeah, we already know group delay is is 1.5. Right? Group delay is 1.5. You just check the graph, you know. The group should be group delay should be e to the negative j, then group delay times it is 1.5 omega. Okay. And after you remove this out, then inside this term, remove this, you have this one left, right? So this is a positive j times 1.5 omega. And second term, 2, you remove a 1, negative 1.5 out. Then you have negative 1 here, right? You remove 1.5, so you need actual 0.5. So here is a j times 0.5 omega. Minus, this is 2 omega. You remove 1.5, you have 1 left. You have half left. E negative j half omega. And okay, this one you remove 1.5, another 1.5 left. Alright, then okay, now you merge these two. Oh, sorry, this is 2 times e to the power. Okay, these two you merge, you will have, as right here, 2 of cosine 0.5 omega plus j sine of 0.5 omega. I have this, right? And second term is negative 2 cosine of 0.5 omega. Then this is a minus j sine of 0.5 omega. So you do summation of these two terms. You have this one minus this one, they cancel. This one minus the negative of this one, so they are summation. So this is, we have 4 of j sine of 0.5 omega. We have this. And similar, these two terms, we will have, you see, you check here. Here coefficient is 2, then here is 4. Now double of it. If you know this coefficient, here should be 2. Now I times 2, I get 2. These two terms, similar thing, but the coefficient is 1 in front of them, right? In front, both are coefficient 1. So here just 1 times 2 of the sine. So it's 2 of the sine. Of course, you need a j still. So this is a sine of, then the frequency is 1.5 omega. Okay, so the summation is j, both contain j, so I move j out. I have 4 of sine 0.5 omega and 2 of sine of 1.5 omega, and j times e to the negative j 1.5 omega. And what is j? I rewrite this as e to the j omega, j pi over 2, because this is what? This is 0 plus j times 1. It is a cosine of pi over 2 plus j sine of pi over 2, right? Pi over 2, sine pi over 2 is 1. And this is e to the j times the angle is pi over 2. Alright, then I can merge this j with the exponential power together. So I have, okay, I write this h again. H of e to the j omega will equal to 4 of this sine with 0.5 omega plus 2 of this sine of 1.5 omega. And this part is e to the, I have this 2, so it is negative j 1.5 omega minus pi over 2. You get it? Alright, so actually this is a general linear, just general linear. Why? We have this one. We have this is a, so the angle of h of e to the j omega is, oh sorry, I get something wrong. Okay, let me finish this. This is the angle is negative 1.5 omega minus pi over 2, or negative 1.5 omega plus pi over 2. So this is a beta. Beta do not equal to 0. This is alpha equal to 1.5. So this is group delay. If you take derivative of omega, it's also same thing, right? Derivative of these with negative, this is a 1.5, the group delay. You can denote this is a tau omega is 1.5, or we write it or the group delay of h is 1.5. Okay, so we have this. Okay, it's not not general, not linear phase. Not linear phase, just a general linear phase. Just general linear phase. All right. Okay, let me go back to this part. Okay, here, yeah, I need to correct something here. Yeah, for type 3 and 4, linear phase. Okay, it is not just this. This is for type 1 and type 2. We can see like that. So this is linear phase. Actually, linear phase in case. In case, I just say in case. You need to check it. You need to check it. Like this example. After we do all this work, we know it is just a generalized linear phase, not linear phase. Just generalized. Just a generalized linear phase. Yeah, you have a bait, it's not zero. You have bait, it's not zero. And actually, this one, if we check it, it might be, yeah, this is all. It is also not always positive, right? Sometimes negative, sometimes positive. So, yeah, this is the case. We can see how the face looks like. Yeah, we need a computer to do it. Yeah, you should know. You just look at this. You should know it is sometimes positive, sometimes negative. Right? Have omega equal to, just choose like from 0 to pi. I just use this. Just use this for the omega. Then we have h in omega. It is HR. I want HR equal to 4 times sine of 0.5 times omega, and plus 2 times sine of 1.5 omega. 1.5 times omega. One too much, like this. Okay. Then okay, just plot omega and the angle of HR. I guess I'm wrong. Oh, omega, sorry. What is omega? Omega is a vector, right? Omega is from 0 to pi. Oh, it's always 1? Why this is a straight line? Oh, sorry, it's angle. Yeah, this is real. Yeah. In my case, I want not. I don't want the angle. I just look at it. Just look at it. Just look HR. Yeah. It's this one. Oh, this is always positive. The sign. Okay, this one is always positive sign. Well, because the frequency is 0 and 1.5. Right. The frequency is a 0.5 and 1.5. So from 0 to pi, then we can have it always positive. This is always positive, but the phase is not really positive. So we can try h omega. We can see h omega, which is h omega is what? H omega this one. H omega this one. H omega this one. So h omega is 1 plus 2 times exponential power of negative j times omega. Okay, I need these a lot, right? Copy. Okay, the first term is 2 times it, and then negative 2 times it, and here I need a double of it, and the last term just 1 times it, I don't need the 2, and here is 3 times. Okay, then we can plot the W with and the phase, the angle H W is here. Okay, this is a phase. Oh, it's a curve. Then I make something wrong. I think 1 and the 2 and negative 2. Here's a negative 1. Sorry, it's negative 1. Here's a negative 1. Here's a negative 1, and then I plot it. Should be straight line. Oh, this is straight line. It is straight line. Straight line, but start from here. Start from this should be half of the pi, right? Half of pi, 1.5 something. Yeah, let's say half of pi. Okay, if this straight line start from the 0, then that half, that slope will be just delay. That is a linear phase. But this one is just generalized linear phase. All right, generalized linear phase. This is type 4. This is type 4. Example of type 4. We can also try. Okay, let me give the. This is the phase, angle of H, e to the j omega. Here's a pi, right? Like this, and here's a pi over 2, and slope is 1.5. Yeah, 1.5. Okay. Then we check another example. H of n. Okay, now we give. I have like I still use this is 1, negative 1. Then gave 2. Then this is a 1. This is a. Oh no, not this. Sorry. H of n equal to. Yeah. This one. This one. If I give this 2, then okay. This is just 0. All right. Then this is this one. This is this one. Like this. This is 1 and the negative 1. 1 and the negative 1. Here's n equal to, okay, 0, 1, 2, 3. N equal to 4. Right? N equal to 4. N equal to 4. So alpha is 2. And this is a type 3. Right? Because the n is even. Alpha is the integer. This is type 3. Type 3. And then, okay, the group delay. It's just 2. It is just 2. And if you want to know more detail to make sure it is a linear phase, if you want, you can also call this linear phase. But you should understand this is just a generalized linear phase. Okay. The h of e to the j omega will equal to, this is 1, then I have 1. This is negative 1, then the minus e to the negative j omega. Then 2. I do not have 2, and I have 3. It's positive e to the j 3 omega, and then negative 1. Negative 1. So here should be minus e to the j 4 omega. Okay. Then I remove the middle one. The middle one now is e to the 2, right? E to the negative 2 omega. E to the negative j 2 omega. I move this out. Then 1, after you remove this out, you have e to the positive j2 omega left, right? So they can cancel. And this one, you remove 2. You only have 1, so you need actual 1 more. So here's a j omega. Right? And this one, you remove 2, you have 1 left. Here's a negative, sorry, negative. You have one left, so e to the negative j omega, one left, right? This one similar. You move 2, you have 2 left. Okay, so this one equal to and you lost it. I do similar thing. These two you merge together, it will be what? It will be, this is a negative of cosine omega plus j sine omega, and second term is a positive cosine of omega minus j sine omega. So you do summation, you merge these two together, they cancel. This is negative, this cosine cancels. This is negative j, so I have negative 2j of sine omega. Okay. And these two, I have this is a cosine 2 omega plus j sine of 2 omega, and this one is negative cosine of 2 omega minus j sine of 2 omega. Then we put them together, cosine cancel, I have these minus and another minus, so positive, so 2j of sine of 2 omega. Alright, then add them together, that will be h of e to the j omega or equal to this is a let me put the positive in front. It's 2j times sine of 2 omega and minus 2j sine of omega and times e to the negative j 2 omega. Alright, I move j out, so this is 2 of sine 2 omega minus 2 of sine omega, this one. And I move j out. J, I can write it as e to the j pi over 2. You can always write this one. This one is just j. Okay, then the e to the negative j 2 omega. Then you can merge that two together. It's 2 times sine of 2 omega minus 2 of sine omega. And here's e to the negative j 2 omega minus pi over 2. Now we can always have this one. So okay, so this time this is so alpha is just 2. Alpha is still 2. Alpha is still 2. We know the group delay is 2, right? Group delay is 2, but it is not linear phase because you have this number. So beta equal to pi over 2, right? Beta is pi over 2. I don't need to merge these two together, just this 2 pi. Okay, anyway, yeah. So the angle of h is negative 2 omega plus pi over 2. Yeah, beta is this one, not 0, so not linear. Not linear phase. Yeah, it's general. Just generalized linear phase. Alright. Okay. Then that's all for today. And so this is Friday. Hope you have a great weekend and see you next week. Bye bye.